This next identity we want to verify. There are many routes that we can take, but we want to start with the thought process of making the more complex side equal to the more simple side, which in this case is going to be the left side being more complex, and we're going to simplify it down to the right-hand side. So we'll draw a vertical line here. This one won't take too long to work out. And you might have one of two inclinations when you work through this problem. You see two parentheses, and you might want to FOIL it out. And if you want to FOIL it out, this problem will work. By all means, go FOIL it out. The issue you run into, though, is when you start FOILing, you're going to have a secant squared sine squared of x quantity. And that's not something that's really easy to work with. If I wanted to, another route I could take is converting everything to sine and cosines. This secant squared of x I could write as 1 over cosine squared of x. Then I've got everything on the left-hand side as being cosine and sines, and I could FOIL it out. That works as well. But the issue you run into is you now have a fraction that you're dealing with. The third way, and probably the most efficient way to go about doing this, is looking at the fact that these both have 1s in it, and they're both quantity squareds, which there's a good chance this can be manipulated into a Pythagorean identity. And this first one right here certainly can be manipulated into a Pythagorean identity. Secant squared of x minus 1 is the same thing as tangent squared of x. And that comes from the identity that 1 plus tangent squared of x is the secant squared of x. All that happened is I moved the 1 to the other side, so secant squared of x minus 1 is equal to the tangent squared of x. The second equation is very similar to that. That's sine squared of x minus 1. Originally, it was sine squared of x plus cosine squared of x is equal to 1. I want to get the negative 1 with a positive sign, so I'd move the 1 over here, which gives me sine squared of x minus 1, which then means the cosine squared has to be moved to the other side, which makes it a negative cosine. So really this expression is tangent squared of x times a negative cosine squared of x. Now that I've got it into single terms, it's easy to write in terms of sine and cosine. So sine squared of x over cosine squared of x is what tangent squared of x is, times negative cosine squared of x. Cosine squared of x is canceled, which leaves me with a negative sine squared of x. The next identity here, verifying the identity, then simplifying it so it's not in fractional form. This one's a one-step verification in that if I take my left-hand side, I can simplify this, cosecant to 1 minus sine of x, or 1 over sine of x is the same thing as the cosecant of x minus the sine of x. Or I could take the right-hand side and take 1 over sine of x and make it cosecant of x. So that's a very simple verification to show that the two are the same. But now I'm going to write it in non-fractional form. So if I've got 1 over the sine of x minus the sine of x, let's start by making a common denominator. So first thing I did here is that this sine of x is going to be sine of x over 1. To make a common denominator of sine of x, I've got to put a sine of x down here, which I need an extra sine of x in the numerator then, which gives me sine squared of x. So 1 minus sine squared of x over the sine of x is my expression. We know 1 minus sine squared of x is going to be cosine squared of x over sine of x. And as you look at that, you might say, okay, well, where do I go with this? Well, let's start by separating this cosine out. We've got 2 cosines in the numerator and 1 sine in the denominator. So let's just string out our cosines. Cosine of x over sine of x times the cosine of x. And cosine over sine is the same thing as the cotangent of x. So this expression in non-fractional form is going to be cotangent of x times cosine of x. The final example that you see here, we want to verify this identity. And this one you look at which side's more complex. And you might look at it and say, I'm not quite sure because I've got fractions on both sides. But if we look at the left-hand side, the fact that we have one plus a quantity and one minus a quantity, those sort of are equal to each other. But this tangent squared of x is a lot more complex than just a cosine of x. We've got a quantity squared, or you could look at tangent as being sine over cosine. So all that put together makes the squared more complex. So this left-hand side with the squared and the expression being added is more complex than just the expression being subtracted in a single cosine. So let's work with the left-hand side, and we are going to simplify it down to the right-hand side. So tangent squared of x over 1 plus the secant of x. Now here there's many routes we could take. We can convert to sine and cosines, but then I've got a fraction over a fraction. So let's start with making not a common denominator, but using the conjugate. 1 plus secant of x, let's start with 1 minus the secant of x. We know that when we do that, we're going to get something that looks like the difference of two squares. So my numerator becomes tangent squared of x, 1 minus secant of x. My denominator, as I said, is the difference of two squares, which will be 1 minus secant squared of x. And 1 minus secant squared of x is going to be a negative tangent squared of x. That's taking the identity 1 plus tangent squared of x is equal to secant squared of x, and moving the secant squared of x to the left-hand side, and then moving the tangent to the right-hand side. So here my tangents cancel out. And now I'm left with negative 1 minus secant of x. Now if I look at my final answer, I need to somehow have cosines in here. And right now I only have secants. So let's see if we can convert those secants to cosines. And we can pretty easily. Secant of x is 1 over the cosine of x. So now I'll work just inside the parentheses. Here I've got a 1 and I've got 1 over cosine of x. We can find a common denominator. 1 over the cosine of x. Oops. I should say cosine of x over cosine of x minus 1 over the cosine of x. We want to find the common denominator, that 1 there, which is then going to be the same thing as the cosine of x minus 1 over the cosine of x. Very close to what we need up here. So we'll continue to manipulate. So all I did right there is I switched the order of my cosine and 1, so negative 1 plus the cosine of x. And the final thing now is if I distribute this negative in, I'll have 1 minus the cosine of x over the cosine of x, which is what I was looking for.